We are moving ahead to solve quadratic equations. Today we're looking at solving them by graphing. And that could be finding an exact solution or estimating a solution when you aren't able to find an exact solution. So I know solving quadratic equations is covered in Algebra 1. So even as we're going through this today, you might be thinking of alternative methods to solve these equations. I know some people in second hour were. But keep in mind, we're getting to reviewing the other methods. There's many methods you can use to solve a quadratic equation. Graphing is just the first one we cover. So graphing is just one method. So on Friday, we talked about the standard or the general form for a quadratic function. That was f of x equals ax squared plus bx plus c. So then today, because now we're looking at quadratic equations, we have the standard form of a quadratic equation is ax squared plus bx plus c equals 0. So the standard form, the equation does have to be equal to 0, but it's still that form ax squared plus bx plus c. A still has to be any other number besides 0, otherwise it's not quadratic. And then in standard form, a, b, and c must be integers. So you wouldn't have decimals or fractions. And then the beginning part of this, so if you haven't already realized this in math, it's not just about going through a process, but understanding why you're doing that process and understanding the vocabulary with it. There's really 4 vocabulary terms that all mean the same thing, so you have to understand what those all mean. If you are asked to find the solutions of a quadratic equation, these are called the roots of the equation. So if a question asks you to find the roots, you have to know that means you're finding the solutions. And then one method for finding the roots or the solutions is to find the zeros of the related quadratic function. And the zeros of the function are the x-intercepts of its graph. So if you also want to make a note, the zeros are the x values that make the y value 0. So that's why they're the x-intercepts, because at every x-intercept your y-coordinate is 0. Therefore, those x values make the y value 0. And then it's called a 0. So this kind of outlines a more concrete example. And again, I know it didn't copy very dark, so it may be easier to look at your sheet. It's hard to see up here. But it gives us a quadratic function, f of x equals x squared minus x minus 6, and then it gives us the graph of the function off to the right. So on the graph, you can see that we have 2 x-intercepts, and the x values of those coordinates are -2 and 3. So the x-intercepts are -2 and 3 is what it says below. And then if we look back over to the left, it shows if you substitute both -2 and 3 into the function, that's going to make the y value equal to 0. So f of -2 is 0, f of 3 is 0. We can also see that from the ordered pairs, the y value for both of those x values is 0. But because when you substitute them in, the y value is 0, we call -2 and 3 the zeros of the function. So x-intercepts and zeros of a function are the same thing. And then the related quadratic equation is now the x squared minus x minus 6, but rather than equal to f of x, it's just equal to 0. And this is just showing that if you substitute -2 into the equation or 3 into the equation, it works out because you get 0, meaning you would have 0 equals 0, so it's a true equation. And therefore, -2 and 3 are called the roots of the equation. That also means they are the solutions. So the roots of an equation are the solutions. To find those solutions, or one method is to graph the function and find the x-intercepts, which are the zeros. So all 4 of those terms mean the same thing. You just want to understand that depending on how it's worded in the directions, you want to know that each of those 4 terms, they're really looking for the same answers. So we're going to look at example 1. It says solve x squared minus 4 equals 3x by graphing. And when you graph, you want to make sure in your equation that it's in standard form, meaning one side equals 0. So your first step, if it's not already done for you, is to get one side to equal 0. And it doesn't matter which side you get equal to 0, so really between you and somebody else, you could have two different graphs based on which side of your equation you got equal to 0, but your solution should still be the same no matter which side you get equal to 0. I'm going to get the right side equal to 0 by subtracting 3x from each side. And then I'm going to make sure to write the left side in standard form. So that would be x squared and then minus 3x minus 4, and then I have equals 0. So your ax squared plus bx plus c, put it in that form. Once you have one side equal to 0, then we are solving this by graphing the related function, which is going to be the function f of x, or y, equals x squared minus 3x minus 4. So it's basically, you take your ax squared plus bx plus c, or you can think of it as you're putting f of x in place of the 0 that's there. And this is where, for those of you that were here Friday, we'll review. If you weren't here Friday, you can see how we graphed on Friday. When you graph a quadratic function, what did we find first? We could find the y-intercept. There were three things we found first. Y-intercept was one of them. So since Grace mentioned the y-intercept, what would the y-intercept for this function be? -4. So if we look back up here, our c value in our function is -4. And remember that your y-intercept is always your c value. The x-coordinate is 0. The y-coordinate is your c value. So I can plot 0, -4. But yes, we found on Friday the axis of symmetry. I just abbreviated that as AOS. And there was a formula to find that. Anyone remember what the formula was? So x equals, opposite of b, or -b over divided by 2a. So looking back up at our function, what is our a value up here? A is 1 and b is -3. So then if we have the opposite of b and b is -3, that's really +3 over 2 times a is 1, so that's 2. And I can write 3 over 2 as 1.5. So at the x value 1.5, I can draw in my dashed vertical line, my axis of symmetry. And then after the axis of symmetry, what did we find? And we went a little out of order because we did the y-intercept first, but what else is there that we can find, or that we would need to find? Vertex. And how do you, so the vertex is a point, how do you find the vertex? So axis of symmetry goes through the vertex, meaning the x value of your vertex is 1.5. Substitute that in to find your y value. So that would be 1.5 squared minus 3 times 1.5 minus 4. And that should be -6.25 for your y value. You can plot that point. And then I did say on Friday that making a table, that's up to you. It's not something where if you don't include a table on your homework quiz or on your regular quiz or test that I'm going to take off. I won't. But if it helps you organize your information, you can make it. So I know I have the vertex 1.5, negative 6.25, and then I have the y-intercept of 0, negative 4. So without plugging anything in, what other point do I know is on this parabola? 3, negative 4. So I can reflect the y-intercept over that axis of symmetry to 3, the x value 3, and then the y value would be the same, negative 4. Okay, so on Friday, I know I said when you're graphing a parabola, if the directions just say to graph, you need at least 5 points. The answer to this question, solved by graphing, is not going to be the graph. It's going to be our solutions. So if you can solve that equation by graphing with only graphing 3 points, that's fine. Sometimes you might need to graph 7 points to get your solution, or 9 points. It really depends on your equation and on your graph. In looking at this, so I'm going to try to give you some hints. From what we went through above, we know our solutions are the x-intercepts. Do not, for this graph right now, just sketch in a parabola and say, well, I think the x-intercept is going to be right here. That is not the way to find your x-intercepts. What you should do is, I know at an x-intercept, the y value is going to be 0. So in my table, I want to see y values of 0, because then I know those x values are the x-intercepts, meaning I want to try to substitute in x values or plot points where the y value is going to be 0. So in this case, when I'm thinking about what x value to plug in next, it would not make sense for me to plug in, say, positive 1 or positive 2, because I know that those y values are going to be in between these y values I already have. That's not going to get me closer to 0. So I want to plug in a value that's outside of what I already have, meaning something that's less than 0 or something that's greater than 3. So what could I try plugging in? Somebody say an x value that we could try. 5. That'd be greater than 3. We can try 5. And this, it's trial and error. You're looking for y value of 0. So if I plug in 5, I would have 5 squared minus 3 times 5 minus 4. And that's a y value of 6. Okay, I'm still going to plot it. It's not 0. It's higher than I wanted to. I went from a point that was below the x-axis, now I'm above. But what does that tell me I should try plugging in now? 4. If there's going to be a y value of 0, it's going to be at the x value 4, unless it's at a decimal or fraction, which we'll talk about in a minute here. So if I plug in 4, I do get 0, which is what I'm looking for. And if I reflect that over, what other x value has a y value of 0? Negative 1. And I could, since I did graph it, if I reflected the 5, 6 over, it would be at negative 2, 6. Okay, so I can draw in my parabola. I have my x-intercepts. And the x values of those points, the negative 1 and the 4, those are your solutions. So you do not need to list the entire ordered pairs as your answer, because think about this, if you're solving this equation at the beginning, the solutions are the x values. So my solutions would be x equals negative 1 or x equals positive 4. Okay, questions on that example? Okay, so you have kind of three categories that your solutions could fit into for a quadratic equation. I'm going to look at the middle one here first. You could get two real solutions, and that's when your parabola has two x-intercepts, so that would be like we just saw in example 1. We had two real answers, -1 and +4. You could also have one real solution, and that would be if you only have one x-intercept, and that's only going to happen if your vertex is your x-intercept, if it's on the x-axis. And then it is also possible to have no real solutions, and that's if your parabola has no x-intercepts. So notice in this case, if the vertex is above the x-axis and it opens up, it's never going to cross. So therefore, there's no solution. That could happen also if it was below opening down. There are solutions to these. They're just not real. That's coming up in Chapter 4, later in this chapter. So that's not something that was covered in Algebra 1. So what could happen, this next part is estimating solutions. So what could happen is, say the example we just did, when we substituted in 4, it wasn't 0. So sometimes you can't find an exact root by graphing. That's what's explained here. But you can estimate the solutions by using the integers between which the roots are located. So what this table is showing and what is said above, it says when the value of the function, this means the y value, is positive for one x value and negative for a second x value, there's at least one 0 between the two values. So in looking at the table, if you look at the y values, we're starting at +12, and then for the next x value, the y value goes down to 3, but it's still positive. Then for the next x value, it goes down to -6. If your y value is going from a +3 to a -6, somewhere in between there, it had to pass through 0. So therefore, this is how you would write your solution. You'd look at the x values and you'd say x would be in between -2 and -1. That would be one solution. X is somewhere in between those two numbers. I don't know exactly what it is, but it's somewhere in between. And then this happens again. You can see the second place it happens when the y value changes from a -2 to a +4, to go from -2 now to +4, again, somewhere in between, it had to pass through 0, meaning somewhere between those x values, there's another solution, and that would be x between 0 and 1. So if you don't have exact x-intercepts at an integer, this is how you would write your solutions. You'd say what consecutive values it's in between. So I have a second example for us to look at, just to review that process. Here we're going to solve this equation. It's already in standard form by graphing. And you'll see in the directions, it's all going to say if exact roots cannot be found, like we found in example 1, you state the consecutive integers between which the roots are located. So we can go ahead and graph the related function, which would be f of x equals -x² plus 4x minus 1. And this time, let's start by finding the axis of symmetry. So for this function, what is the a value? -1, yes. And then b is 4, c is also -1. So for our axis of symmetry, if x is the opposite of b, that would be -4 over 2 times a. So 2 times -1 is -2. -4 divided by -2 is +2. So at the x value, +2, I can draw in the axis of symmetry. And then for the vertex, I know the positive 2 is the x-coordinate. I can plug that in to find the y-coordinate. So this one, just be careful. I know I included one like this on Friday as well. The a value of -1 stays outside, so it's -1 times 2 squared. That does not become -2 squared. It's exponents and then multiplication, and then plus 4 times 2 minus 1. So I would do 2 squared first, which is 4, and then multiply by -1. So that is -4 plus 8 minus 1. And that would be 4 minus 1, which is 3. So 2, 3 is the vertex. And then what's the y-intercept for this graph? X-coordinate is 0. What's the y? -1. The c value. And then you're not required to make a table. I'm just going to make one. What other point do we know without plugging anything in? We reflect our 4, -1, yeah, because this is our vertex, so we want to reflect over that line. Okay, so for this one, something a little different from the last one is your vertex right now is above your x-axis. Your other 2 points are below, meaning if we're passing through the x-axis, passing through 0, it's going to happen in between the values we already have. So the only 2 values that would make sense to plug in to look for your x-intercepts would be +1 or +3. They're both going to have the same y value, so it doesn't matter which one you plug in. I'm going to plug in 1 because that's probably easier. So I have -1 times 1 squared plus 4 times 1 minus 1. So again, this would be 1 squared first, which is 1 times -1. So -1 plus 4 minus 1. So 3 minus 1, that's 2. So both of those y values are 2. Okay, so I did not get a y value of 0, and I don't have any other integers to plug in to get 0. So if I draw this in, I can find my x-intercepts 2 ways. You could look at your table or just draw your graph. So notice from the table, I have, I'm going to highlight it like I did above. From the x value 0 to 1, my y value is going from a negative to a positive, meaning somewhere in between there it had to be passing through 0. And so I can even see on the graph between 0 and 1, I do have an x-intercept. So one of my solutions is an x value that is between 0 and 1. The other one then, again, if I'm looking at the table I made, I see I go from a positive y value to a negative y value when my x is changing from 3 to 4. And I can also see on the graph between 3 and 4 is where it crosses a second time. So my other solution is when x is between 3 and 4. But I don't know the exact value of x, so that's how I would write the solution. And when it says to use or states the consecutive integers, that's what this means. 0 and 1 are consecutive, 3 and 4 are consecutive, one right after the other. So, for example, you don't want to say there's 1 between 0 and 2 and then 1 between 2 and 4. You want it to be consecutive. Questions on that example? Okay, the last one I have is also estimating solutions, but using graphing software. So If you have your computer or just in your groups, if you want to all look at one computer, that's fine too. We're going to use the Desmos graphing calculator. So again, either get out your computer or just one at least for the group that everybody can see. So you can either search desmos.com and then click Start Graphing, but you just want to be at the actual graphing calculator that we used for scatter plots earlier this year. All right. So I'm going to be flipping screens because I need to still show the example that's on our sheet. As I read through this, I'm just going to highlight what could be useful information. If I see they're giving me values of something, I'm going to highlight it. So we have the highest bridge in the U.S. is the Royal Gorge Bridge in Colorado. It tells us, here I'm given a value. So the deck is 1,053 feet above the river. And then it says, suppose a marble is dropped over the railing from a height of 3 feet above the bridge deck. So a marble is dropped. The other value we're given is the height it was dropped from. So a height 3 feet above the bridge deck. I'm going to highlight the question it's asking. It says, how long will it take the marble to reach the surface of the water? So it's always good to know what you're trying to find. Ultimately, we're looking for how long it takes to reach the water, the marble, that is. Assuming there's no air resistance, and then it gives us a formula. Use the formula h of t, that's like your f of x, equals negative 16t squared plus h sub 0, where t is time in seconds, and h sub 0 is the initial height above the water in feet. Okay, so usually with problems like this, and I think this is why students typically don't like them, they just give you a lot of information. You have to know how to organize it. If it helps to highlight things as you're reading through or underline as you're reading through, to then pick out what you need. And then just notice it's always good to highlight or circle or underline what the question is even asking so you know ultimately what you're trying to find. Okay, so if I am to use this formula, and ultimately we're talking about a marble that's being dropped. So I'm just going to rewrite just so it's separate from all of the typing here, what that formula is. In order to use this formula, we need to have a value for h sub 0 in this case. And ultimately it's saying h sub 0 is the initial height, and we're talking about the initial height of the marble above the water in feet. So in your groups right now, just take, I don't know, 15, 30 seconds. I want you to look back at the problem and come up with what is the initial height of the marble in feet. It might not seem as obvious as it looks. So what is the initial height of the marble? Bless you. All right, anyone think they have it? Grace? 1,056. How did you get that? Yep, so the deck is this far above the water. The marble is 3 feet above the deck, so it's even 3 feet higher. So 1,056. All right, so I'm going to rewrite the function and plug that in. So this ultimately is our function that we are using. And now we have to figure out how to use it to answer the question. The question is, how long will it take? So I am trying to find an amount of time. So I'm just going to make a note to myself. I'm trying to find t. How long will it take the marble to reach the surface of the water? So if I'm trying to find t, that means I'm substituting some value in for h of t. H of t is really h. It's representing the height overall, not the initial height, but the height. So if h represents height above the water, if the marble reaches the surface of the water, what would you say the height is? 0. Yep, if h is height above the water and you're at the surface, you're not above the water at all, h would be 0. So ultimately, this question is asking you to solve this equation. 0 equals negative 16t squared plus 1,056. So this is like the equations we just solved in examples 1 and 2. We can solve this by graphing our function and finding the x-intercepts, or in this case they would be the t-intercepts, but the x-intercepts on the graph. So this is where you can use Desmos to graph, because this is going to be a function that is a little bit higher values than would fit on a typical coordinate plane. So in Desmos, how you type this in doesn't matter. You can type it in exactly how you see it. I can type in h of t, it does recognize function notation, equals negative 16 t. If you want t squared, there's 2 ways you can do it. You can open up or show the keypad, and there is an a squared key that if you type in t and then hit that key, it'll give you the exponent of 2. Or, just so you know this, your keyboard has a caret key as well. If you hit shift and then 6, it'll bring it up to the exponent so that you can type in any exponent you want. And then plus 1,056. So you can type that in. And I'm going to show you something, even though how your screen is right now, it's totally fine because we're looking for the x-intercepts and we can see them. But you cannot see the entire graph of the parabola. If you wanted to see the entire graph, like the vertex and everything, this is very zoomed in. So I can click this minus sign to zoom out. However, actually that was probably farther than I needed to. So here, when I zoomed out, here's my vertex, but now my x-axis is way too far zoomed out. So I'm going to go back to the graph settings and change my x-axis back to be negative 10 to 10. Again, I'm just showing you this. If you needed a complete graph, we could have left it the way it was to begin with. But now this gives you a nice looking graph of the entire function. Vertex, And the x-intercepts, we see it's a parabola that's opening down. Now, what's nice about Desmos is if you click, like if I wanted to know where the vertex was, I could click here. It'll show me, now notice, like my vertex, I have a gray point. I also have it at my x-intercepts. You can hover over it, it tells you the coordinates, or if you click, it'll keep the coordinates there for you. So this vertex is at 0, 1056. We don't need that for the problem, it's just information I wanted to show you. Here are the two x-intercepts though. Negative 8.124 and positive 8.124. Look back at what the question is asking. Does it make sense to have both of these answers? No. Which one makes sense? So if we're looking for the time it takes to reach the surface of the water in seconds, negative 8.124 seconds doesn't make any sense. We're not going back in time. So this would be the answer to our question. It takes 8.124 seconds. So the marble is really starting up here at the vertex and being dropped down, and here's where it's hitting the water. So if I go back to this screen, I can say the marble reaches the water after 8.124 seconds. But that's a better estimation than if we graphed this one by hand. So you can use graphing software as well. Questions on that one?